YouTube is that they won't give you any money until you've reached like $100 worth of ad revenue sales, okay? I've been live streaming all of my classes for, I don't know, 4 or 5 years now. Guess how many times I've gotten paid by Google? Twice. Anywho, so I'm a YouTube penny heir, right? I get once every other year, you guys allow my wife and I to go have like a nice dinner, right? That's about it. All right, well, let's jump into today's stuff. I wanted to start with a very, very simple little review of some of the concepts and the ideas that we explored last week, because in every sense, we're going to build on them this week, okay? That's kind of how this process is going to go for the next about month. And so the concepts on day 1 are being built on day 2, and so on and so forth, okay? So last week, one of the challenges, probably the biggest challenge that we had, was taking this specific rig, okay, and getting it to a point where we can have all the wheels roll around, maybe control it a little bit more globally, okay? So walk me through the process of rigging our little catapults. What did you guys end up doing for your homework?
Following your example.
Good. No, that's good. And that's not cheating, by the way, okay? That's really, really not cheating at all. I think a lot of folks, they think, oh, a step-by-step tutorial is kind of, sidestepping the academic and learning process. Not for rigging, okay? This is a technical process, right? We are going in kind of machine thinking and in an order of operations. If we deviate from that path, even by one step, the machine that we're building fundamentally just isn't going to work. So the answer of watching your video and following along, that's a good answer, because that's how most of us learn, especially the rigging stuff, okay, which is very kind of right brain, okay? It's actually all right brain stuff, okay? It's not very creative at all, okay? So what's the first thing that we probably should strive to do here? Let me rephrase it a little bit and come at it from a different direction. What's the goal here? What are we trying to get our catapult rig to accomplish? So we want to rotate the wheels, right? Okay. Now, before we start thinking about the machinery and what we physically need to build, let's talk in generalities. What's going to control the rotation of those wheels?
The locator.
I like it. So some other locator within the scene, right? Because we don't want to have to go in and hand animate the wheels. We want them to automatically roll for us as we kind of cruise throughout the scene. That's cool. We can do that, okay? So just within that kind of general context, we know that we have to have a locator that's going to be kind of like our master controller, and then we need each wheel to hook into that master controller somehow to get their wheels to rotate. Say again? And the arm. The arm is kind of pretty much all ready to go. We're going to talk about the arm here in detail as we explore the new stuff. I find it most helpful when I'm kind of tackling a rigging problem, or just a rig in general, to have a really good, solid understanding of what I want this rig to do, okay? Because remember, there are no super rigs, right? There's not one rig to rule them all, okay? There's not some magical fairy dust that I can sprinkle over these models to make them all behave and work perfectly at every single level, okay? We intelligently design them. The rig is only going to do what we build it to do, right? So naturally, we really have to understand before we go too much further what the expectations for our rig are going to be, okay? So our expectations for our rig is that we have some sort of master controller, okay, that will allow us to select that controller, drag it around, and transform it in the scene. And then as we move that locator around, we want all the wheels to rotate appropriately. Okay, so let's start with the low-hanging fruit. The low-hanging fruit, of course, is going to be that master locator. If you remember from last week's conversation, we can go over to our toolbar and insert a locator. Let's name it. I name things the moment I create them so I don't get confused. If we have a whole long list, and I mean this is going to get, just wait until next week, okay, when we start doing characters, okay? We're going to have 200 things that are all named locator, okay? We need to name them as we go. So I'm going to call this just master control, okay, or root control, whatever, something that makes sense for you. Out there in the real world, you see people use root often, which is kind of our buzzword for master, okay? Like the root of the tree. Everything stems from the root, okay? Also, while I'm here, let's just change some display properties for my for my locator. I love these shape properties, by the way. I think they're pretty fantastic. I'm going to make a custom one. Let's make it a circle. And we're going to align it to the y-axis. There we go. And, I don't want to align to view, sorry. Axis set to y, and then I'll increase the radius quite significantly. That's kind of fun. In addition, let's also choose to make it just a nice little outline. Now, one of the things that we can add into this, if we'd like, and you'll see this in some of the videos that I've posted inside the week 3 module here, is that we're certainly able to go in and encourage to place some colors in here. And you can find all that color information in the display section of your properties. If you do add draw options, now we can go and change the color, which is pretty cool. So I don't want the wireframe color to be the default. I'll do a user-defined color, and let's just pick a lovely shade of yellow. And now, when I deselect, I know it's kind of hard to see on the projector, but when I deselect that locator, it's yellow. Okay, or the wireframe color of that guy is yellow. Okay, we'll come back to those color things a little bit later, but let's keep moving on. So our master control is established. It's looking pretty great. Now let's begin to tackle the conversation or the creation of the rig for each one of the wheels. Now, based off of what we learned last week, in order to get something to move and rotate and be animatable, what does it need to sit on?
A ground.
Not a ground. Let me rephrase it. What does it need to be in?
Workspace.
Not a workspace, but I like the way you're thinking. Its own item, right? The animation system inside of Modo is an item-based animation system. So if I want to have each one of my wheels rotate independently, what do I have to do first? Yeah, separate them out into their own items, right? That way I can control them individually. So let's just do that real fast. And I'm just going to do it on one, because it's like watching paint dry, you know? Okay, so I'm on the catapult mesh object. And let's do this. I want to make my life a little bit easier. I'm going to hide all that stuff. And then look at my scene from the top so I can make a real simple marquee selection for just that wheel component. And I'm simply just going to cut and paste that geometry into its own mesh item. There it is. Okay. If we return to our item list and expand what we've done, let's rename this. It's not a mesh anymore, or the name isn't going to be mesh. Let's just call it Wheel 01. All right. In addition, and before I go too much further, I want to unhide the geometry I hid previously so I can see the total contents of my catapult rig now. Okay. So based on one of the things we talked about last week, what's the next step? We've established that we've established the wheel and its own item. We'll be able to control it independently now, rock and roll, that's what I want, okay? However, if I was to hit the Y key and activate the item transform tool, where is this wheel going to rotate around? Its pivot point, whose default location for every item is where? The origin. So what's the next step here?
You move the pivot to the wheel.
You got it. We get the center of the pivot point to the wheel itself, okay? Now we have two steps here that two options. We can either exclusively grab the pivot point, move it to the center, or we can grab the center point, which shares the same location as the pivot point, and move it to the center of the wheel, okay? Either of those two things are going to work just quite perfectly. I'm going to do the center point because it saves me a click, okay? So with the Wheel 01 item selected, I can change my selection state over to centers. And grab it. Now, I need to move it, and I should have aligned my work plane before. But you can move these things, right? You can move them around the scene, and I'll just get mine kind of close. The center points and the pivot points in our scene are editable items, so they're not static. However, I want to work with a little bit of accuracy here, because I need that center point basically in the center of the wheel itself, okay? This wheel has a whole bunch of, kind of ancillary pieces, right? It's got the hub, those cool little bracket pieces. I don't know what they're called. I'm not a catapult maker, okay? Although I did make this model. There's some other pieces in here that we need to be aware of. I want to have my center point be in the center of the wheel itself, basically right on that edge selection. Now, what's a fast, easy way for us to align the center point to the center of that edge loop? The work plane. Absolutely. The work plane is awesome, and it really is the ticket in Modo, okay? This is the reason I choose to work in Modo. I can't live without the work plane anymore.
Instead of putting the center wheel, I put on the side of the wheel.
Yeah, it would. I mean, what's most important is that it's in the center of, in this case, what would be the XZ plane, okay? Excuse me, the ZY plane. I messed up. I apologize, okay? Its location along the X-axis is kind of arbitrary, but let's put it in a position that makes, kind of spatial sense. That's logical. So I have that edge loop selected. If I go up to the top of the screen to my work plane options, this is where it gets fun, because I can align the work plane to my selection. Now, right now in the setup layout, the work plane is invisible, okay? And that's actually a good thing. However, if we return to that same work plane drop-down menu, we have a really great option, and I actually really like this. This is one of the things that I gave the developers a big high five for when they put this in, because sometimes it's just best to visualize where the center of that grid, that work plane, actually is, and that's where draw axes comes in. This is pretty great, because now I can see visually where the center of my work plane is. Ha-ha! Yeah, baby, that's what I'm after. Once again, if I return to my center's selection state, I can select my center point. However, this time, I'm going to go down over here into my setup toolbar. And of course, under the set category of options, I'm going to choose to work plane position. And this is going to move the center point for this item to the center of my work plane. Boop, there it is. Now, before we go any further, and this is a landmine that people step on, you got to reset your work plane. Why? So it's not aligned to our global kind of understanding of the XYZ axis, okay? But every tool, and I really mean every tool, references the current orientation and location of the work plane. Check it out. Here's the proof of the pudding, right? If I change the view of my scene from perspective to top, normally, what would you expect to see? Yeah, the top of the catapult. However, in this particular moment, okay, everything references the location of the work plane, okay? So the moment you're finished using it in a custom capacity, reset the work plane back to its global orientation along the XYZ axes. Reset work plane. Bloop. And there it is. You can see it just chilling back down there at the origin of the scene. I'm going to turn off my draw axis. Yeah, awesome. Now we're ready to go. This is good. Okay? If I was to select my item, my wheel, and just test it with a simple rotation, aha, awesome sauce. That's what we're after. Okay, so I would literally follow suit for the remaining 3 wheels on my catapult. Okay, so what's next? We've separated the wheel out. We have that master controller. We've separated the wheel out. We've centered the center point for that wheel in the area that we want it to spin around. What's next?
In the setup tab, I don't know what it's called though.
Okay.
Set up the relationship between the wheel and the master controller.
I like it. Absolutely. So let's start making some relationships. Because right now, if we were to go in and simply select the master control and move it around, ain't nothing going to happen, right? What do we want to happen? Everything to move, okay? However, so let's just go and start making our parent-child relationships. So last week we spent a lot of time in both our lab, our homework, and in class talking about the tenets of a parent-child relationship. How do we create one easily inside of the Modo item list? Drag and drop. It really is that easy, which is pretty great. So I want the catapult, the body of the catapult, to follow the root controller. So I'm just going to left click and drag the catapult on top of this locator. And when I mouse up, a hierarchy has been created. Let's test it. I'm a big believer that the moment that you create something, test it so you understand if it's working the way you want it to work. Yeah, there we go. Okay, that's good. We're on the path now. However, what's next? Yeah, so what else needs to be parented to the master controller, the root controller? The wheel and the arm. Okay, so let's get those two in our hierarchy and test the conclusion of that step. Get that in there, go. If we select our master controller, hit the Y key, yeah, there we go. Awesome. I like you. That's good. Okay. So now comes the fun part, right? Getting the wheel to work in tandem with that master controller. What part of our rigging environment do we need to have open and available for us to make these connections? Does anyone remember what that window's called? Kinda. It's called the schematic workspace, okay? It's important that we have our terminology correct, okay? Because there are, within the schematic workspace, there are sub-workspaces. So the schematic workspace is muy importante, as they say, okay? Now, I have mine minimized, and I did that just by maximizing the viewport. So I'll click on the gold arrow just to kind of get everything back. And this is my schematic work environment, okay? It's pretty cool. I like the schematic environment. It allows us to make some pretty awesome connections between the various elements inside of our scene. So let's start getting the participants of our wheel system in the schematic. Now, I know I want to have the master controller, that root control locator, determining the rotation of our wheels. So that's going to be a primary driver of this entire relationship. How do I get that exposed and available to us down here inside of our schematic? Yeah, you both are saying the exact same thing, just click and drag. Okay. Now, when we left click and drag from the item list down into the schematic, what's available to us is just kind of a representation, a blank node. And check this out. If mine looks a little bit different from yours and you're wondering why, this is yellow because I changed the color of my locator to yellow, right? Great way to start kind of highlighting and separating out these functions, okay? Colors are a great way to organize your thoughts. All right, so I have the root representation of that item, but I don't really have a channel yet, okay? And if you remember from last week's conversation about working with this control locator, I'm going to select it over in the item list. This channels tab is going to expose every animation channel that's available to this item, and there are a bunch. Most of these channels are common animation channels. We can even create our own, which we're going to do today, which is pretty neat. So what we're looking for in here is world position. Okay, so this is going to take its global position inside the XYZ space, and we're going to use that global position to drive rotation. Okay. How do I get this channel into my schematic? It's great. This is how cool. This is drag and drop, right? I can drag it from the channel list into the schematic work environment, and then boom, there it is. Okay, this world position channel is now available for us to make connections with. So what are we going to be making a connection with? Or a connection to? The wheel, right? So let's do the same thing. I'll drag it down into the schematic. There's its global kind of representation, its default node. Okay, but I want the position of my root controller to influence the rotation of my wheel. So once again, with that item selected, I can return to my channels list, and let's do, what rotation value is it? It is rotation X, okay? So here's what if you don't, oops, I deselected on accident. If you don't see rotation up here, just hit the Y key, or excuse me, the R key, I don't have it selected. The E key, I'll get it right one eventually. Oh. Yeah, and then once you rotate or change that value ever so slightly, it pops in. This is actually called a transform item. More on this much later. But what we're trying to expose here is just this rotation X channel. You could do it that way. Another easy way that you could do it, if you don't want to go into the channels list, is just go to your properties tab with that item selected. Because really what we just need is that thing right there. This is another great way. You can right-click on this row, and then down in this crazy long contextual menu, there is Add Channel to Schematic. Okay, there it is. Ah, awesome, wonderful. So we got rotation X. So this is the big picture idea. I want to send the position information from this control locator out over to there. Okay, and I just simply did that by left-clicking and dragging on the terminal here. You generate what's called a noodle, and yes, that's technically what it's called, a noodle, which I love, by the way. Okay, so we go from terminal to terminal with a noodle, and this is cool. I love how Moto does this. See how it goes red? Red is the universal sign for what? No. Okay, stop, do not pass go. Okay, we want it to be green, and the reason why it's going red is, if you think about it, we're sending position information, which is what? What kind of unit of measurement is used to calculate position information? Distance stuff, so feet, inches, meters, stuff like that, right? To a rotation channel. Now, what do we use to measure rotation? Degrees, okay? So we need to have some sort of converter here in the center that will accept the position and then spit out rotation information. This is called a modifier, a channel modifier. They're kind of like translators in my mind, okay? We're going to add a very specific channel modifier called a revolve modifier. We can add it easily by going to the top of our schematic into this add section. You're more than welcome to click on the button. You're going to get this cool little browser. This is something that the Foundry has kind of implemented across every menu. And if you just type in revolve, there it is, pops in. That's one way of doing it. If you like to search for things, this asset browser is really cool. I already know what it's called and where it's located, so I'm going to click on the white arrow and go channel modifier, other, revolve. Okay, 6 to 1, half a dozen to another. You get to the exact same place either way. So let's add it into the scene, or excuse me, into the schematic, and here we go. Now we're starting to make some connections, or now we have at least the components that we can wire together to make our connections. Okay, so world position of my control locator. If I left click and drag on the terminal, I'm going to feed that into the position input on the modifier, right? Cool. In addition, look at the outputs, because these are all ins. These are ins. That's kind of the terminology, the convention that's used. The left side of every node is the input side. The right side is the output side. So we're outputting angles, percentages, distance. What do we want? Angle. Okay. So I'll left click and make that connection over there. All right. So now let's test it. If I grab my control locator, fire off the Y key to activate the item transform tool, I can move my control locator forward. You can see that that wheel begins to move just quite perfectly. Pretty cool, huh? Pretty cool. Okay, that was basically the conclusion of our rig last week, just rinse and repeated, you know, for the other 3 wheels. It's the exact same system. And FYI, you didn't have to have 4 complete systems, by the way. You could use this one, these 2 things could be the common elements, okay? Because the size of the wheels and all that jazz are basically going to be the same. Let me just show you what I'm talking about. Let's do another one. I'll hide all this. I'm going to just extract this part once again. Okay. Let's just do the setup for this super fast, like I did earlier. Align my work plane, grab my center point, align it to my work plane, or set it to my work plane, excuse me. I'll reset my work plane, and then check it out. Just bring that down there. And on wheel 2, rotation X, oops. There we go. I'm just going to test it here real fast. Oops. It was not in item mode, I apologize. Yep, it's working, cool. So now check it out. I can actually take this one angle output and send it to multiple places, okay? Yeah, now they both work. Okay, that's cool. Pretty neato, huh? Pretty neato. We're sending information from one object into another object. It's incredibly powerful, okay? If you begin to explore all the channel modifiers inside of the schematic, we can do some pretty fun things in here, right? Especially when it comes to, because we're just sending information, we can intercept that information and change its information whenever we want. You know, you can go in, for example, and do channel modifier. Let's do math. Let's do this. Let's do an add function, okay? You can capture, intercept that signal, then output it. And then down here in this second slot, if you just click on the math modifier, you can say what value b is, and let's do, I don't know, what are we going to do here? We'll add, so we're thinking in degrees, or maybe what we should have done, maybe we should have done like a divide, or like a multiply. Yeah, let's do that. Let's do a multiply. So we can change the math here. Let's multiply it by 3, 5. Why not? Yeah. So any information that's being sent from the translator is going to get multiplied by 5 over here. So what do you expect is going to happen here in the back wheel? It's going to spin 5 times faster, right? Let's just test it. Yeah. Whee! Cool, huh? And of course, the inverse is absolutely true as well. If we multiplied it by 0.5, okay, then it'd be spinning half the speed, things like that. So we can do some pretty heavy lifting math. I saw a rig once, which was crazy, and this is where this kind of speaks to the power of the moto rigging system. If you start to look at what you can add in here under modifiers, the one that drives me crazy is the conditional stuff. Logic. Now we can begin to ask questions as if certain conditions, or if certain conditions have been met, which is kind of nuts. I saw a rig for a padlock, okay, and you had to rotate each little spindle on the padlock to the right combination before the big U-shaped mesh item would be available to open and rotate. This is like a working padlock that was rigged, which I thought was just like, that's crazy, right? That's crazy. We're not going to go into that because I don't even think I can do all that stuff, but it can get pretty heady pretty fast. It should, yeah. It should, because if we did it by a negative value, then, you know, instead of being sent, hey, you're going to rotate 90 degrees, you're going to rotate negative 90 degrees. Yeah, that's a fast way to get it to spin the opposite direction. Let's just test it real fast since I already got it here. If I multiplied that value by -1, now, I bet you anything, the front wheel is going to be, yeah, the rotating opposite directions. Yep. Cool, huh? Yeah, it's neat. It's good stuff. It's good stuff. All right. Okay, so any questions on that? As a reminder, of course, naturally you have the live streams that I would highly, highly, highly encourage you guys to go back and use as a refresher. If you explore the content inside of our course, here's week 2. Here's everything that we talked about last week in small, consumable videos. You're going to get the same amount of attention this week under the week 3 section. We have 2 things that we're going to talk about that are kind of new. We're going to talk about set-driven keys, and there's even a small little lab assignment that I hope that all of us can do in class together today that uses set-driven keys as kind of a nice enhancement for the type of detail we can place in our rigs. And then we're going to end the day by talking about constraints. Okay? Some really great videos. The constraint stuff is a lot of fun. Yes, sir? Are you live today? Absolutely. Live streaming at the very moment. People are even watching me on YouTube right now, which is kind of fun. So let's start off by looking at the set-driven keys lab assignment. And this is something that we're going to start working on, and I would highly encourage you to kind of follow along. I've given you guys this very lovely model down here. Actually, let's do this. Let's just, since I got my catapult open, let's just look at the foundation of set-driven keys with this project file, since we're really accustomed to working with it, and it's a really simple model file to use. Okay, so here's the big idea, because it's always important that we understand the outcome of this. What are we trying to achieve? Now, the arm of my catapult, and you guys probably experienced this last week when it came to animating your catapult. Yeah, it doesn't really follow the rules, okay? And of course, the geometry can pass through each other. There's a range of motion here that I want to capture, right? I want the range of motion for our animators to be somewhere right around in here, because there's nothing worse than having some sort of cross penetration of two meshes to break the illusion that we're trying to create, right? So I want to try to make my catapult arm a little bit more functional and restrict the range of motion of this object. Okay, we can do that easily in what's called a set-driven key, where we're going to be able to basically go in and say, you're here at this moment in time, or this is the location of the arm at this value, and this is the location of the arm at the other value. Hopefully, if we do our job correctly, we can get this down into like a little slider that our animators can control, right? Because how cool would it be if they got their own like little HUD, their own like little interface, and they just move a slider and then things like rotate like that on the rig, where they don't even have to go in and select anything. It just automatically behaves the way we want it to behave, right? That's the goal, okay? I want to restrict the movement of my catapult arm and create a little interface, if you will, for our animators so that they can control this part of my rig easily, okay? We do this with what's called a set-driven key. All right, I'm going to hit undo. I want to return the rotation value of my catapult arm back to 0. And now we get the fun part. And this is actually really kind of cool, okay? Now we have to create some user channels, okay? And this is where it gets a little bit complex, because I want to be able to go in and control the amount of rotation. That I can do already. But how do I make it stop at certain, kind of areas inside the scene? We can do that with a custom user channel. Now, a minute ago, we were checking out some animation channels. Let's just look at the arms. The channel list here. Check out, look at all this stuff in here. These are all the animation channels that are available to this item, and there are a lot of them in here, okay? We're going to create our own, and we're going to define pretty quickly a start value and a stop value, okay? So remember, kind of like a slider. At 0%, the arm is going to be looking like this. At 100%, the arm is going to be looking like this, okay? I don't know what those values are, and I wouldn't want my animator to go in and start messing with rotation values. I want a start pose and an end pose, and a slider that will attenuate between those. Okay? Creating custom user channels is really, really, really easy. We had to pick a home, some sort of warehouse, if you will, that this data is going to be stored in. It's a good practice to put this kind of warehouse or these custom channels on the master controller. Because how cool would it be if we were to select the master controller and then we get a little interface that allows us to drag and slide a whole bunch of things around, and our little toy behaves and changes things automatically for us, right? That'd be kind of neat. So the warehouse for these custom user channels is going to be, on my rig at least, on our master controller. Okay? So with that master controller selected, and there it is, okay, I'm once again going to go back over to my tool properties. There's a lot of tools in here, okay? Welcome to the setup layout. There's a bunch of stuff going on. We're going here to the modifiers collection of tools. And at the very tippy top of that menu is going to be Add User Channel, okay? This is a custom channel. This is something that I'm creating and defining kind of its parameters. Let's look at the popover that we get when we add our own channel. Okay, this is what it looks like. All right, so we have to give it a good name. Okay, this is a must. What are we going to name our little channel that controls the rotation of our arm? Arm mover. Why not? I don't know, right? We want to make it something logical that everyone's going to understand. Arm mover. Oh, I was not supposed to hit return there. Okay. Let's try that again. I'm so accustomed to hitting return after typing that sometimes, okay, so arm mover. Now, the moment you click off of this input field, it's going to populate the channel name based off of your username. This is fine. Leave it as its defaults, okay? You're never going to see the arm mover channel name, kind of all squished together. That's on the back end of the Modo database. You're never going to see it. All we're going to see is the name that we create right above, okay? Now, the type of information that we're going to ask the computer to create and calculate, so let's talk about it. We're not going to talk about all of these because we'd be here, as you can see, forever. There's a lot of data that we can create and ask the computer to manage. It's important that we understand a couple of these, okay? So we have a float. This is a number, okay? What type? So floats are number values. Now there's a difference between float and integer, which is also a number. What is that difference? Decimal points, okay? So an integer would be a whole number, like 1, 2, 3, okay? A float would also be a number, but now we have a decimal point in there. So it could be 1.01 or 2.54, okay? And get really, really, really specific, okay? So we have float, number, very granular number, okay? Small micro movements are allowed, okay? We have integers, which are big whole numbers, okay? And then the last one that I want to talk about is percentage, and I think that's pretty obvious. Just is 0 to 100%, okay? So percentage is going to look like this. So 0% all the way to 100%, okay? And that's what I want to use for this particular operation. I want to have a percentage value where 0% equals arm like this, 100% equals arm like this, and I'll still be able to key in and animate all the differences between 0 and 100, right? So I'm going to choose the percentage type. There we go. Mode scalar, that's fine. It says, hey, give me a number. Okay. The default value is 0, and this is the part that I would really encourage you to enable just right off the bat. You can come back and add this layer, but it's a whole lot easier if you did it now. So the minimum value is going to be 0. The maximum value is going to be what? 100. If you don't set a maximum value, you can continue to push this channel past 100. Okay? If you're comfortable working inside of Modo, you'll probably remember that there are a lot of channels, especially in the shader tree, where you can push the value past 100. Okay? I want 100% to be my stop. Okay? Now I'll hit the return key or the gigantic OK button to save that in. If we go down to our channel list, okay, there it is. Now, once again, I have my master control locator selected, and the channel list at the bottom is showcasing me quite wonderfully my custom user channel. Yay! Good. Yes, sir. Right now, it's not a button yet, okay? We can go in and manually input information into this section, okay? But I don't want to yet, okay? I want a slider that I can go and control. Yeah?
Oh, I meant right under that. Add user.
That's another way you can add a user channel. Yeah, this is a custom user channel. This is the same button as we just clicked on inside the form on the left. All right, so what are we going to do with this, okay? We have this thing, and here's kind of a cool thing. Notice that I have my custom user channel selected, okay? This is fun. If you hit what's called the channel hull tool, keyboard shortcut C as in channel or Charlie, okay? Watch what happens. Here's your little interface, okay? Oops. And then here's your little slider, arm mover, okay? You can go left and right with it. I'm all zoomed in, so it's kind of going crazy right now. We'll come back to this here in a minute. All right. And then if you hit the C key again, that channel hull tool will dismiss the form. All right, so what are we going to do with this? Much like we did with the schematic, I want to go in and make a relationship. I want to say, hey, when my custom user channel is 100%, I want the rotation of my arm to be this degree, okay? When my custom user channel is at 0%, I want it to be this, okay? Now, we want to make a dynamic relationship between these two items, and we can do that pretty easily in what are called the channel links, okay? This thing right here. So if we click on channel links, you'll get a popover. This seems like a very scary environment, but it's not, okay? We're going to be loading an item that's going to be the driver. And then we're going to be loading something that's going to be the recipient of all of this information. In the Moto world, this is the driver and the driven, okay? Now for us, let's take a guess. What's going to be the driver of this relationship? Custom user channel, arm mover, right? I want the percentage of arm mover to influence some sort of rotation value on my arm, on the catapult arm itself. So the driver is going to be the custom user channel, and then the driven is going to be a rotation channel on the catapult arm, okay? The first thing that we need to do is load the item, okay? And we're doing an item now that contains the specific channel that's going to be the driver. For us, that's going to be the master controller. And I just want to make sure that it's selected. Once it's selected either in the viewport or in the item list, you can simply hit load driver. It loads all of those animation channels on the left. Okay? What's going to be the driven? Catapult arm, right? So with that selected, I can load it under the load driven button on the right. Okay? Now, the channel links menu does a really great job of reminding you which items are currently loaded as the driver and the driven. At the very top, you can see the item name and all of their associated animation channels.
If you have a locator for your arm, would that be the driven?
You certainly could. Yeah, that'd probably be okay. All right. So now comes the fun part. We've loaded everything into the channel links menu. Now we got to go in and physically make a connection between the two channels. So I want to scroll down over here on the left until I find my custom user channel, which is called, arm mover. Okay? And now I need to find and understand my catapult. Let's see, if I fire off the rotation, it is, so I'm looking rotation X. That's what I'm after, right? So arm mover is going to influence rotation X, okay? I'm making a connection here. Arm mover is going to drive the rotation X channel for this object, okay? Now, if we did direct link, whatever information is currently housed inside of arm mover will just be sent directly over here. But this is percentage information. How in the world are we going to be able to control rotation, which is degrees of rotation, right? So instead of doing direct link, we're going to do a relationship. Okay? This is a chooser. We're not actually doing anything yet. Okay? So I'm going to choose the relationship style. Then finally, I'll manually create the relationship by hitting add link. Okay? All right. Now, let's see. Why am I not seeing the channel links thingamajig? Okay. So if you are like me, hold on a sec. Let's make sure my visibility is all on. Why am I not seeing my channel links? There should have been. There should have been a popover. Let's try selecting it again. Okay. Pause. Why am I not seeing what I want to see? There we go. Because they've changed it. How dare they? Okay. So the reason, I don't know why they changed it. It used to be when you just hit the add link button, a popover would just automatically show up. Okay. Mine wasn't showing up. So here's what I did to get that interface back. If you go over into your item list, underneath your arm, check it out. There's a little plus sign now. And inside that plus sign is the actual relationship. If you click on that little greenish yellow gear, this is what I was after. Okay? And I'm zoomed in, which is why it's going crazy. Oh. I'm sorry, say again?
You have to do it with the arms, because I had a locator for the arms, so it doesn't show up.
It didn't show up.
Link.
Change it to relationship. Because you're on direct link. We want relationship. Well, for you, you may have to go back to direct link and remove it. Remove the link first. Change the type to relationship. And now add link. The driven channel is animated. Oh, you have keyframes already applied to this. This isn't going to work.
Okay.
Yeah, yep.
I'm having a similar problem.
Okay.
I have the, obviously the link, but there's nothing popping up still.
Okay. Let's see.
No.
There it is. Yeah.
I was just...
Okay. So what are we going to do with this? This is an important little chunk of interface for us because it's going to allow us to go in and physically set the rotation values of our arm to a certain percentage value. Okay? No, that's not the correct interface. Let's do this. Okay, select arm mover here, down there. Okay, and let's select rotation X. Yep. And add link. There we go. That's what we want. Well, hold on 1 second. Let's see, because you should have a little plus sign next to arm. Let's hit undo a step.
How much?
One more time. Keep going.
Oh.
That's good. Okay.
Okay.
Can you scroll all the way to the tip top of that form?
Oh.
Yeah. Okay. So you have it flip-flopped. Okay.
Okay.
Yeah. So scroll all the way to the top here.
Okay.
Let's just see what's loaded in. Keep going all the way to the very top. Okay. Oh, yes. Yeah. Master controller, master controller. This one over here needs to be your arm. So load it. So it's selected.
Okay.
So hit load driven. There we go. Now we can make the relationship. Yep.
Okay.
Okay. So let's take a look for a second as to what this little menu allows us to do. First and foremost, here's our arm mover, and this is going to work. I apologize if it's going to be difficult to see. I can't move these sliders when I'm zoomed in. And you can preview what it is that you're working with, okay? So 100%, 0%. And then you got rotation down here, and you can even click on the word. Yeah, you can click on the text, rotation X, not the number, but the actual word. See how I'm interactively changing the rotation of the channel that I made a relationship with? Go back in time. Okay? So you can have fun with this, preview it, go crazy, you know. I'm going to put this back down to 0. Okay? All right. Now the next thing that I want you guys to pay real close attention to are these things in here. These are not VCR play controls, like play and animation. Okay? This used to get me stumped all the time when I first started working with this, because what does that big square mean in our kind of in our world? Stop. It means stop. If the developers of the Foundry are listening to my live stream, they need to change this icon, okay? Because it in fact does not mean stop. It means key here in the set-driven key workflow, okay? What we're going to do here is that we're going to key a value between 0% in some sort of rotation degree on that arm, okay? So before I key it, let's change the rotation of that arm. And I got to figure out what I want 0% to look like. Okay? So rotation, I need to go back this way. And what is it going to be? I don't know. Somewhere right around there. I'm just looking to see if there's any sort of occlusions in there. Yeah, that works. Okay? So that is what I want 0% to look like. The arm almost entirely back like that. Okay? So with that in tow, look what happens. I've made a change. My key button's now gold. Okay? And I can key it in. 1 of 1 represents the keyframes that you've applied. Okay? All right, so we've keyed in the 0% position for my arm. Now, I'm going to go back to my arm mover and move this up to 100. Okay? 100%. Well, what do I want my arm to look like when it's at 100%? I want it to be somewhere, I don't know. Let's figure it out. Right in there. That may be the logical stop point. I'm getting way too accurate for a Friday. There we go. Aha! Wonderful. And last but not least, and this is the mistake that everyone makes, is you got to key it in. You got to preserve it. Okay? Now it says 2 of 2. You haven't saved it. You haven't keyed it in and retained that kind of stop position until you hit the yellow square. When it says 2 of 2, mission accomplished. Let's test it. Okay? Because while we're still here inside this world, I can take it back to 0, 100%. 0, 100%. Off, on, off. There it goes. Yes, sir. Yeah, Mike, go ahead.
After you make the, what's it called, the user channel?
Yep. Mm-hmm.
Can you still change the center or the pivot point to a different location in case you're not happy with where it rotates?
Yes, absolutely.
Okay,
Right.
good.
Yep. You should be able to, at least. You should be able to. Yes, ma'am. Yes. So if you don't see it, close down.
Here.
It's there. Close that down. Channel links down. Yep. Don't want that anymore. Click off of it, like click something else, like another item. Click back on it. No say. You're in item mode. Let me no see it. Let me explore this. Let's see if we can find, because you can dismiss it by just clicking off of it, but clicking back on it should give you that. Okay. Let's see what's different between yours and mine. So let's do this. Let's return to channel links just for 1 second. Oh, yep. And let's see the connection. It says relationship bar to bar position. This may be your problem. Because what are the two members of our bar to bar? So bar. Okay. Do load driver there. Okay. And then go grab bar and do load driven.
So this was.
Okay. That's your custom user channel.
Yeah.
Right? And then you did
Position X.
position X, and I can see the little icon there.
And it's on relationship.
It's on relationship. Wonderful. Go ahead and click the plus icon. I'm just confirming. Yep. Okay, great. That's a good question. Let's do this. Let's click on it again.
Just click out of this.
Yeah. You're in item mode. Yep, click that. Now, I wonder if it's being disabled because channel hull is currently on. I don't know. Yes, there it is. Okay, so we just made a discovery, and this actually honestly just may be a change that I wasn't aware of, okay? If your, let's see if I can recreate it. If channel hull is on, okay, and you click on your little gear, see what doesn't pop up, okay? So if you're trying to do this set-driven key relationship thing that I was just working on, and you're not seeing it, and I think that was my mistake as well earlier, turn channel hull off, and then you should be able to click on the gear and get the interface. Okay? Yeah, let's go through that. And here's what I'm going to do. I'm just going to delete that relationship, okay? And you can just simply right-click on it and delete it, and I'll go through the entire thing one more time. because it is one of those things you have to do it and practice it a couple times before it gets comfortable, which is why you're going to be doing it like 8 times in the lab assignment here today. Okay. Excuse me. So a reminder on the setup. Excuse me. All right. So on my master controller, my root controller, I've already gone ahead and created a custom user channel called arm mover. Its type is percentage. Now, if you messed up on that, okay, you made it like float on accident, okay, you could always just right-click on your custom user channel and do edit user channel. Okay, you get almost the exact same series of controls back in the little popover. So it's not written in stone. You can go back and fix it if you messed up. All right. So with that selected, or you don't even have to have it selected, let's go to the channel links button, and I'm going to load my master controller as the driver, because it's the warehouse, the data warehouse, if you will, for my custom user channel. Next, I'll grab the item that I want that custom user channel to control, which in my case is the arm, and I'm going to load it as the driven. Now that we have both items loaded into their respective slots, I need to make the relationship. Select arm mover, which is my custom user channel, and I want it to control the rotation X values of my catapult arm. Since I want to be able to define the angle that I want my arm to move within, I want to create a relationship so I can key in and establish those start and stop points for the rotation of my arm. So I'll click relationship. So this is a chooser, and then I'll physically create the relationship by hitting add link. Okay? I can see the interface behind my channel links pop over. I don't need this anymore. And I'm free to start physically going in and making the connections. Okay? So if you remember, the first thing that we have to do is to key in some values. But actually, I guess that'd be the second thing. I apologize. The first thing would be to set the rotation of your arm to where you want it to represent 0, like percentage completion, if you will. Okay? So let's just do that real fast. I'm going to click on the word rotation X and move it to the right until I'm roughly getting what I want. Yep, the little bolts on the top there. I'm being way too much of a perfectionist. There we go, that's good enough. And then once I have that established, notice that that white cube, which is the icon for keying in this relationship, is yellow. So I've just saved that, I've just keyed and saved this rotation degree to be assigned to this percentage. Okay? Now I'll change my driver's percentage to 100 and then change the rotation of my arm to whatever I want it to be when this channel is set to 100%, which is somewhere, I don't know, there-ish. Why not? And then again, last but not least, we can't forget to save it in by clicking on the yellow dot, or the yellow square, excuse me. So before we drop the tool and move on, test it. Drag that slider, the top one, and you can see that at 0%, the arm's down, and at 100%, the arm's at its stopping location inside of the scene. Okay? That's the goal. That's what we're after.
Oh yeah, one more thing I actually just figured out about the channel whatnot. That might be obvious to other people. You can only see the channel in item mode, so if you're another selection.
Got to be in item mode. Yeah, absolutely. Yeah. All this is done at the item level, for sure. All right, was everyone able to do this with their catapult? Yeah? If you haven't been following along, follow along. Okay, this isn't one of those things where you're going to learn by osmosis, just by watching me do it. You got to get your hands dirty, as they say. All right. So let's put this into practice a little bit more. Okay, we've seen the system in tow a little bit. Let's actually finish the job. I want to get it out of this. There it goes. Simply deselecting the relationship over in your item list will make that little interface go away. Okay, so how do we get it to show up? Excuse me. Or how do we use it, right? Because right now it's on that item, it's on my master controller, but I don't want to have my animators go way down over here. Open up the channels list, find the custom user channel. There could be 8 of these, 8 or 12 or 2,000 custom user channels on an item. I don't want my animators to go in and be forced to find and to know which ones are custom and which ones are not. So here's what we're, excuse me, here's what we're going to do. The first thing that we have to do is that we have to select our custom user channel, in my case, arm mover. With it selected, I can once again return to my properties panel. Inside of my properties panel, we have this assembly section, which we were in last week for a moment. Now this is pretty neat. I like this assembly section because it allows me to do any number of things when I click on this item. Okay? Check this out. This is actually kind of neat. If under the utility section here, I can say fire off a command when I click on it. When I click on the locator, I can do these things, or I can do any number of things, right? I can even go in and write my own if I want. This is just a command. So we're going to choose, well, let me just illustrate this for a second. If I choose transform tool, okay? Now when I click on that locator, bloop, the transform tool is automatically going to fire off, okay? That's cool. So anytime I click on that locator, the transform tool is available to us now. That's kind of fun, okay? Really great for animators, right? But we don't want the transform tool to fire off, so I'll go back to the assembly area, and under the utility category, I want to choose, I have to make sure that my custom user channel is selected first. I think it was, but I don't remember if it's still. So I got my custom user channel selected. Now I can go to that assembly area and choose item channel hull. Okay. Now when I drop the tool, click on the locator, it automatically fires off the channel hull tool and selects that custom user channel. Okay. So now we're in the process of making a little interface. I just simply hit the C key to dismiss it. Can click on it again. Can animate it. I'm on my way. Cool, huh? Pretty neat. Pretty sweet. All right. So, questions on that? Everyone good? Kind of understanding it? Okay, let's put it into practice a little bit. Now it's your turn. Okay? If you roll over to our or roll back to the week 3 module in Canvas, I've given you guys a small, little simple assignment here. Okay? So here's our goal. I've given you this car model. Many of you guys are already fiddling with it. Awesome. Okay? If we look at the car model, it's a pretty good looking car model. I did not model this, by the way, so I can't take credit for it. Sorry, I'm not that awesome. Although I am pretty awesome. Okay. So set driver keys. If you look at the actual project file itself, it's a pretty big car. Whoops. Let me reset my work plane here. Okay. So, and if we explore the contents of our item list here, of course we have interior, tires, body. Okay. Your mission, if you choose to accept it, and you have to because it's an assignment, so sorry folks. Your mission is to get this car operational, okay? Your mission is to make a rig to control the basic functions of this car. I want to have a rig where the wheels rotate independently just like our catapult, but then here's the fun part. I also want you to rig the functionality to open the doors, okay, and the trunk, okay? Set-driven keys. It's all about set-driven keys. So, with that said, since the wheels, passenger, driver's side door, and trunk are all going to be custom animated objects, what do they need to be extracted into? Their own items. That's the first part of this. Okay? The wheels are going to follow suit from the catapult. It's identical in setup and in function. And then the doors are going to use that set-driven key process that we just explored here in class. Okay? Now, if you're still confused on the set-driven key stuff, keep it in a simple environment like the catapult. That's why I wanted you guys to practice with the catapult. Okay? It's a little bit easier to understand the moving parts and pieces in a simple environment versus a more complex one. Okay? Then, once you're really comfortable with it, once you've gotten your catapult arm to do its thing, kind of like I was doing, then maybe graduate into the car. Sound good? All right. Questions? Kevin? Okay, let me just change something on the live stream real fast, and we'll get going. Okay, so this is the first time I've used this particular project file for this assignment. And there's some bugs. You know, the first pancake's never perfect, so let's figure out what the bugs are, okay? First and foremost, there's probably a couple issues in here that you guys ran into, and let me return to the one that I was working with, okay? So I have a simple little rig here, okay? Actually, let me go back in time. That's fun, isn't it? Yeah, so I just rigged it real fast. You can see my wheels are flying off all over the place. There we go. That's okay. So we have some problems here. And for you guys were probably noticing that you moved the master control and the wheel would spin, or it would actually spin probably like 8,000%, but it only looked like it was spinning 1%. So here's the problem. The big problem with this rig, or with this model, if we look at the original, okay, first and foremost, there's two things. A, it's gigantic, okay? So if we look at the actual dimensions of this thing, its length is 3,129 feet. So it's humongous, okay? It's huge, okay? Now, the size of it doesn't necessarily, I mean, I can work with the size, that's okay. But also, look very carefully. If you notice that your wheels were spinning the opposite direction, look very, very carefully at the direction this car is facing inside of our global XYZ space. Which direction is it facing? The wrong way. It's facing the negative Z versus the positive Z, okay? Problem, it could present some problems, okay? Now, the size of the car, no big deal, but the orientation of the car, humongous deal. Got to fix that, right? Got to fix that one. So let's, I'm just going to simply, before I get too much further into this, let's go make a polygonal selection here. So I'm just going to rotate the polygons. I'm not rotating the items, I'm rotating the polygons, okay? I'm doing a component level edit. I'm not rotating the item because I don't want to preserve that rotation in my transform item over my properties tab, right? So I'll just rotate the polygons before I get before I get going. I'll just do -180. Here we go. All right. Now, at the very least, it's facing the right way. However, we now have a dark door. Okay? Awesome. With computer graphics, you fix one thing, you break another. Welcome to every moment of the rest of your lives. Okay? Usually when you see the computer shading a series of polygons like this, here's a go-to culprit. And you saw this actually last week with the wine barrel that you're importing back into Modo from Substance, right? There was that errant vert map, or excuse me, the errant normal map that the FBX file was bringing with it. Well, we have something very similar. If we return to our Lists tab under Other, vert normals. I didn't make this. This came with the project file. If I just clear or delete that map, my shading errors go away. Now, Modo's creating the normals for every single one of the vertices on the mesh, not that map. Okay? All right. So that problem solved. Computer graphics is all about solving problems, right? So let's get the scene file to a point. So it's under the Lists tab. Other maps. Yeah, you got it. All right. So you got it. That's the one. I think I'm just going to grab this front tire here. Oops. Excuse me. There we go. I'm going to grab that front tire, cut, just like our catapult. Paste. Call this wheel 1. Go. Unhide everything. Make sure you're good to go. Okay, cool. So now wheel 1, it's in its own mesh. Aha. Awesome. Let's work in item mode, please, Pat. There we go. I need to move its center point, just like I did earlier. So let's go in and move some things around, just like we did with our catapult. We'll align our work plane. Grab my center point for that mesh, which is currently over there somewhere. Let me make sure I got it. There it is. And then naturally, over in our setup tools, we'll do 2 work plane position. Okay, there we go. Now, at the very least, we can begin rigging that one wheel. Okay, let's get that locator in real fast. And if you had a problem with the size of your locator, the radius, that's because your car is 3,000 feet long. Okay, the radius, these are actual, we're working with actual values for a lot of this stuff. Yeah, so if I do under my shape, circle along the y-axis, this has got to be more than 20 inches, okay? Let's make it, I don't know, 500 meters. Yeah, now we're talking. Okay. Now it's beginning to look and behave like something we saw with the catapult, okay? Now the schematic thing, I think Indigo had a wonderful strategy, okay? Great strategy, because here's what some of you guys were running into, right? The wheels were spinning just like crazy. Let's get all the channels in there real fast. So I want world position. Okay. And then for wheel 01, I want to have rotation X. Okay. All right. Let's add the channel modifier, just like we did earlier, the revolve channel modifier. And if we plug it in, just like we did with the catapult, this is what we're going to get. You guys are probably experiencing this. Yeah. It works. Look how fast that mother's spinning. Okay. That's humongous. You just move it a little bit. Yeah. This is very interesting. Let's actually see. We'll move the car forward 10 feet. How much does the wheel 01 rotate? It rotates almost 180 degrees. That's not what we want, right? So we have some things that we can and should look to change in here. As I mentioned a minute ago, the size of the car, that's not a deal breaker. I can make that work because there's one little hidden Mickey in the revolve modifier. And this isn't something we went over last week because we didn't need to. But this is a cool little trick, and this is absolutely a power user trick that someone showed me once, and it's rad. Check this out. Inside the revolve modifier, if I select it, of course, it has its own channels, okay? And if you look carefully, there's also a radius channel. Ooh, interesting, okay? Of course, it's right there, too. Same thing, literally the exact same thing, okay? So if I add this radius channel to my schematic, check it out. It has an input. What if I knew the radius of my wheel? Okay? This radius channel in the revolve modifier is a direct influencer of the angle output value that it creates. Okay? It's a factor inside this entire equation. So it's on the revolve modifier. So if you just click on the revolve modifier, properties panel will show you all the channels. Okay? And it's just right there. Radius. And I just right-clicked on it and chose from the popover, add to schematic. Add channel to schematic. Okay? Now, I don't know what the radius is. I mean, I could guess. I could probably use my dimensions tool to figure that out. That's fine, okay? But let's go at it a little bit more from a sneaky kind of way. Let's have the computer figure it out for us, and let's do it in a way that's a little bit more artistically driven versus something that's more mechanical in nature. So let's do this. I need to figure out, let's go through the logic behind this. I need to figure out the radius of my wheel so that I can send that little chunk of data to this channel. Is there anything that we've kind of been experiencing and working with so far that produces a radius value? This is cool. The view dimensions tool, that will give us the diameter. We need a radius though, right? Radius is half the diameter. Yeah. You can do the math. I don't want to do the math. I guess that's what I'm trying to say. I don't want to do the math, right? Pat doesn't do math, okay? I can do the math, but Pat doesn't do math, okay? Check it out. This is actually kind of cool. A locator, okay? A locator, standard locator. This is actually the root controller for my car, whose shape parameter has been turned to circle, produces a radius channel. What if, this is kind of crazy, okay? What if we produce an additional locator whose sole function is to generate the size of a wheel, is to understand the size of a wheel? Let's just do it real fast. I'll make my locator. I'm going to call this wheel sizer. Okay, and like I did earlier, I'll change the shape to custom. I want a circle. Doesn't matter. You can either do circle or cylinder, by the way. They both get the exact same thing. circle. I'll make it not solid, and I want it aligned to the x-axis. Okay. Now we could simply move it into location. Now it's going to have to be pretty big, like a little too big perhaps. At least now we're in the relative scale. Okay, I'm going to look at my car from the side so I can really figure this out. Now if I wanted, I could get super geeky in the placement of this. Okay, let's get super geeky. Because I could use the power of the work plane to align. There we go. Align things pretty accurately. Align my work plane to that edge. And go grab that locator and say to work plane position. Now I know beyond any reasonable doubt, oops, forgot to reset my work plane. Now I know beyond any reasonable doubt that that locator, which is wicked hard to see at the moment, is in the exact center of the wheel. Okay? And now I can just explore the radius. Okay, somewhere, I'm getting way too geeky about this. Right around there. Visually, that's pretty close. Okay. I want to make wheel sizer a child of my entire system. That way it comes along for the ride. And then, check it out. I'll return to my schematic and add wheel sizer into the system. And with it selected, I'll add the radius channel here to my schematic. Okay. The output of the wheel sizer radius is going to be the input for the revolve radius channel. And now I bet you dollars to donuts. If I can find it, where did it go? Hello, Mr. Locator. Oh, it's at 12 inches. That's why. I was like, why am I not seeing that? There we go. Now when I move this, yeah, check out. Check it out. It's rotating correctly. That's a cool little hack. That's a great trick for having the computer do all the math and do all the heavy lifting for you. I just want to visually line things up.
If you change the car, then too, you can just adjust the size.
Bingo. Yeah. Yeah, if you scale down the car or scale it up, you can just change the size of that wheel size or locator, and then all the information is going to flow through the schematic, and your wheel will rotate appropriately. Hopefully.
Closer to a general car, right?
Closer. Okay, with that said, let's take a break. Okay, now's a good time for a break. So it's 3:04. Let's be back in here at 3:15, please. Okay. Took a little bit more time out of our break than we normally would, but that's okay. It's Friday. All right, so what I've done here is that I've returned to Canvas just for a moment, and I've downloaded and opened a project file under the week 3 section on Canvas called Working with Constraints.zip. So if you want to follow along, and I highly encourage it that you do, please download and open. In addition, just because I like colors, I just assigned some basic colors to my 3 little shapes here just to make it fun and cool, okay? You don't have to do the colors if you don't want to. So, okay. So inside of this project file, I have 3 different items. I have an arrow, a little target, and a big target, okay? Our goal this afternoon is just to explore how constraints work. Now, we've been working kind of within this constraint system with the set-driven keys that we've been building pretty much all day today, okay? However, there are some, I hesitate to call them presets, but they are kind of like presets. They're really defined rules that will allow us to make relationships between collections of channels between different items. Because with the set-driven keys, we're basically saying this singular channel is going to affect this other singular channel. But what if I want like all 3 rotation channels of my blue ring to influence all 3 rotation channels of my green ring, okay? When we're working with large collections here, these are called constraints, okay? And they're really easy to create and apply to the different objects that we have inside of our scene. So let's go ahead and make a couple right now. So again, I'm in the setup layout, and if you go down to the modifier section inside of our toolbar, here are all our constraints. Now, we're not going to go through all of these, but you can see that there's a lot of different connections that we can make between the different items in our scene. We're going to go through a couple of them, a couple of the big ones. Yes, ma'am?
I cannot find some sort of geometry. Like
You can't find.
yeah, like I don't know what's happening exactly.
Hit the A key. Okay. I don't know either. Let's do this. Let's reset our work plane. I can see that it's been enabled. Yeah, that was it. Yeah. You only do that 4 or 5 times before you go, okay, I got to reset my work plane. I actually did that earlier. Sometimes you walk away from the idea that you've aligned it. Anywho, okay, let's get into it. They're pretty neat. There's some really great constraints in here that will allow us to quickly make some significant connections and relationships between our different items. Let's start off by working with the big target and the little target. Okay, I'll just deactivate the visibility of my arrow. Okay, and now what we're going to do is create our first constraint. It's called the position constraint. Okay, however, let's just be very, very clear as to what these constraints are really kind of ultimately doing. I selected my big target, my outside ring. And of course, naturally, at the center of that object, we see its local center point and its local pivot point, okay? These center points and pivot points are now something that we need to manage directly. Because in every sense, the relationships that we're about to make have everything to do with the location of the center point for each one of the items involved in this little relationship, okay? So it's the center points are what's important, and you'll see that here in a second, okay? So the position constraint. It's really easy to create a position constraint, or any constraint for that matter, but the selection order is really important. Much like we saw last week with the parent-child relationship that we created, we're going to select the child first and the parent second. So in my mind, I'm saying I want this green ring constrained to the blue ring, okay? The child is always selected first. The parent is selected last. So if I grab the green ring, hold down the shift key, grab the blue ring, now once 2 items are selected inside of our scene, all of my constraints become active in my toolbar. And we can start applying these different constraints to our 2 different items. So I'm going to use position constraint. Zoom out. Click. Did I click on it? I did not click on it. There we go. Now I clicked on it. Now, if you look very carefully, a couple things have happened. If I move around my big target, you can see that my little green target is coming along for the ride. This is not a parent-child relationship. This is a position constraint. We are taking the position of the green target, the little small one in the circle, and we are saying to the computer, hey, you are going to be in the exact same location as the position of the blue one, okay? Not a parent-child relationship. We're constraining the position channels to each other. If you look over here in your item list, we can see that position constraint pretty clearly. Click on the plus sign. There it is, okay? That little green gear is something that we need to kind of look towards, okay? One of the great things about position constraints is that we can, or constraints as a whole, is that we can delete them, okay? And we can continue to modify them, with the properties of the constraint itself, okay? All right. So I could simply, if I didn't want this, or if I got it wrong, I can go over and just delete that position constraint. And now when I move my blue ring, see how the green one doesn't move? Okay? So here's another great visualization that this is not a parent-child relationship. Note on my screen, I've taken my blue ring and I've pushed it way far away from that green ring. Okay? If I was to parent-child, these two together, what would happen to the location of the green ring? If I just dragged and dropped it inside of the hierarchy, or to create a hierarchy over in our item list, okay? So if I just did this, whoop, what happened to my green ring? Nothing. It stayed in its current location. Functionally, I could move this thing, and and it actually rotates, okay? You can scale it up. The child will also get scaled. That's a parent-child relationship. Now, with a position constraint, we're overriding the position transform channels of the child. So in our case, the green ring, the small one. Let's do it one more time. Which one, if I wanted to constrain this item here to this item back there, what's the first one that I'm going to select? The child, in our case, the green ring, okay? So I select it, hold down the shift key, grab it over here, and then watch what happens when I apply the position constraint. It goes back, okay? We're sending all of the position information from the blue ring, and we're overriding that to the green. This is a constraint, okay? Yes, sir?
If you remove the constraint, does it take the transform away?
Let's find out. So, this object over here has been pushed back almost 24 inches along the z-axis, okay? If you look at the transform channel of its constrained child, everything's at 0, 0, 0, right along its transform. If we were to delete it, it goes back. It releases those channels from the influence of the blue ring, and it's going to honor whatever is inside of its local transform channels.
When you're constraining, it's always taking it to the location, rotation, direction of the parent.
Just with the position constraint, we're just overriding the position values. Yep. And this is a little bit more superior to, well, not superior, it's just different from the parent-child, because the parent-child relationship overrides everything, right? And it doesn't replace it, it just comes